Hello. Welcome to this episode of Criminal Mischief, the Art and Science of Crime Fiction. I'm D.P. Lyle, your host. Today I'm going to begin a three-part series on forensic toxicology. So this will be part one, which we will talk about poisons and drugs and toxins and what they are and the basics of toxicological testing and how to interpret some of the testing, how to collect the samples, where they're best taken in a dead body or even a living person, and then how it relates to the cause and manner of death. These are critical determinations for the medical examiner. In part two, we're going to look more at the testing procedures as to the screening and the definitive testing and how that all works and what happens in the lab and how these tests are interpreted to make a case or break a case. And then in the third episode, we'll talk about some common poisons and that are used in crime fiction all the time. So let's begin with a general discussion of what is a poison. Well, you hear the term poison and toxin and drug, and they're used interchangeably, and indeed, from a medical and forensic point of view, they really are because any drug can treat an illness. It can become toxic or it can become a deadly poison. Um, Anything can be a poison. The basic definition of a poison is any substance that, if taken in sufficient quantities, causes a harmful or deadly reaction. The operative term here is sufficient quantities. Anything taken in a large enough amount can cause a derangement of the physiology of the body that can lead to illness and death. Anything. Water. Water can kill you, and I just don't mean by drowning. If you drink too much water, ingest too much water into your system, it changes the electrolyte content in the blood. These are things like sodium, potassium, and chloride, the things that are in the bloodstream that make the nerves and the heart and everything else function. They have to be within a certain range. And sodium can get washed out if you drink too much water, and the sodium level can start to drop. Say it's normally around 135 to 140. It can go down in the teens, even into the 108, 109 range. And what happens then? Well, osmolarity, that has to do with how the a liquid moves electrons and moves chemicals back and forth, but the osmolarity of the blood changes. When the sodium gets very, very low, uh, the brain swells. A person can have seizures. They can have death from this, and this is called water intoxication. Now, this happens in some psychological things called compulsive water drinking, and these people will drink gallons of water every day. You can even tell them, this is the reason you're in the hospital, because you drink so much water. Oh, I'm sorry, I won't do it again. And, and a month later, they're back in the hospital again with a water intoxication. Um, it's psychogenic polydipsia, which means you're crazy and you're drinking too much water. It happens all the time. It can happen when we're giving IV fluids in the hospital. If you give the wrong fluids, like D5W, instead of a saline solution, you're loading the system up with water, but without the sodium chloride, the salt in it, and a person can become water intoxicated. Oxygen. Oxygen can be deadly. You say, well, wait a minute. Isn't that needed for life? Yes, it is. But remember, the normal oxygen concentration in inspired air and room air is about 21% oxygen, about 70% nitrogen, and then some other things. But it's about 21% oxygen at sea level. Obviously, that drops as you go to altitude. Um, but what if someone gets put on 100% oxygen, which happens in the hospital a lot? People who come in with pneumonias or with heart failure or some other damage to their lungs, so they're not able to extract enough oxygen per unit of air that they breathe, then you bump up the amount of oxygen. That's fine. That's temporary. That works. But if you leave someone on 100% oxygen for a period of time, 2, 3 days, it can damage the lungs by changing some of the chemicals in the lungs, and I won't get into the details of that. But now the lungs become damaged and scarred. And we call it adult respiratory distress syndrome is one of the terms used for this. But oxygen can directly damage the lungs. So anything is a poison. It's all a matter of uh, how much is present. So a medicine that you take for any reason, if you take the normal amount and you have a normal reaction to it, then it's a medication. If you take too much of it, it becomes toxic. And if you take way too much of it, then it becomes deadly. So toxicology itself, particularly in the forensic world, is basically a marriage of chemistry with physiology. In other words, you're looking at chemicals, but you're also looking at the effect of these chemicals on living organisms, or at least organisms that were at one time alive, like a human. Um, so the forensic toxicologist deals obviously with the legal aspects of toxicology because his questions is there a toxin present? Okay. Is there one present? First of all, you got to decide that. Then, did it cause harm or death? And what was it? And was the intake of the poison accidental, suicidal, or homicidal? We'll talk about that a little later. Those are the questions he's got to determine. Is something present? Is it in sufficient quantities to do harm? And how did it get there? By what purpose and by whose hand? Now, one of the principles of toxicological testing is that often you don't test for the thing you're testing for. Now, that sounds a little incongruous. Well, here's the problem. Drugs undergo biotransformation. Just like when you eat food, it gets digested by enzymes and acids and things and gets converted into other things that can be absorbed into the bloodstream, whether they're amino acids and proteins or sugars or whatever, and can be absorbed into the system. But they've been biotransferred by a chemical reaction in the stomach and the gastrointestinal tract. Okay, that's normal. If you take a drug, any drug, it will be metabolized. In other words, it will be acted upon by the chemicals within the body, often the liver. There are other areas that this happens. The liver seems to be kind of grand central station for all of these things. And it breaks this drug down because if not, it would accumulate forever. You know, you take a medication for something, you take it every day. Why? Because it lasts 24 hours. Why? Because the liver is constantly destroying it. Well, what does it do when it destroys it? I mean, it doesn't just evaporate and disappear, snap, gone. It breaks it down into metabolites or breakdown products. It alters that chemical into another chemical or chemicals, and then those become inactive and they leave the body, usually through the urine or the GI tract and the feces. Sometimes they're exhaled, but mostly urine is involved here. And so a lot of this biotransformation, this metabolism, is to break down the drug so it no longer works. And number two, put it into a chemical that can be eliminated from the body. And that's why you got to take your medicine every day. So let's look at cocaine. Someone takes cocaine and say they die from it, an overdose. It happens all the time. Used to happen a lot more 25 years ago. Um, well, when cocaine enters the bloodstream, by whatever method you ingest it or snort it or smoke it or whatever you do, when it gets into the bloodstream, it gets acted on by enzyme and is broken down and basically into three breakdown products or metabolites. The active one is norcocaine. That's the one that gives the people the buzz and the high and the thing they like about it. And then a couple of other products that I won't bore you with. But the point is it's broken down into three things. So if the toxicologist tests for cocaine, he's not going to find it. But if he tests for norcocaine, then he's going to find it. He's going to find its presence and its levels, so he can then make a judgment. Did it have anything to do with the person's actions or the person's death or whatever happened? Same way with heroin. Heroin comes from morphine, and there's a chemical process that converts heroin into morphine, and we're going to talk about that in the later part of this. And but as soon as you take the morphine, inject the morphine, it is immediately converted back into a form. I mean, as you take the heroin, it is immediately converted back into a form of morphine. So if the toxicologist tests for heroin, he won't find it because it doesn't exist anymore. It has been broken down and changed almost immediately. And so he has to test for the breakdown product, which is a form of morphine. And that's the active ingredient, and that's what makes you crazy. Now, very few toxins and poisons ingested by the body leave physical signs. In other words, the medical examiner or coroner is not going to go into the autopsy room and say, "Oh, this looks like X toxin." Very few do that. The classics are cyanide and carbon monoxide. They interact with the blood to form a bright red carboxyhemoglobin or cyanohemoglobin, depending on whether if it's carbon monoxide or cyanide, which create a hemoglobin that is bright red. So now the body looks more pinkish. The internal organs are more pinkish looking. Um, the blood is brighter red. And often this can be seen in the lividity, that the settling of the blood, the blue, gray, black areas when the blood settles in the dependent areas of the body after death. This can be take on a pinkish hue rather than the grayish bluish hue in cyanide and carbon monoxide poisoning. Interesting, can also happen in hypothermic deaths. I won't bore you with that. And it's because of this chemical reaction. And so the medical examiner might see that. Certain metallic poisons, the heavy metals we call them, like arsenic and mercury, can lead to terrible changes in the gastrointestinal tract and the liver that can be seen anatomically. Carbon tetrachloride, which for many years was used in carpet cleaning before it was banned, will destroy the liver literally within hours, and all of that fatty degeneration of the liver cells can be seen at autopsy. But in general, the person just looks dead. There's no outward sign. So now the medical examiner has to become a true investigative um, scientist. He doesn't really know what he's looking for, but he suspects there's a poison. So he's got to start searching somewhere uh, to see if a poison had anything to do with this person's death, or maybe just erratic behavior, such as alcohol and drunk driving. So where's he going to look for these things? Well, first of all, it's blood. And blood is critically important. Again, in fact, it's the single most important, because think about it. Whether if you inhale something, inject something, or swallow something, it has to get to the bloodstream before it can be distributed through the body and have an effect. If you take a sleeping pill, it doesn't work until it's broken down in the stomach and absorbed into the bloodstream and then reaches the brain, and then you get drowsy and go to sleep. But if it doesn't get in the bloodstream, it's not going to have any effect. This is called bioavailability. And what that means is that it is available for biological action. And that means it has to get into the bloodstream. And this is important because this is a place where for most toxins, this is a place that the toxicologist will look, is the blood. Okay, let's say that someone is found dead in bed, and they do the autopsy, and they find that their stomach has a handful of partially digested sleeping pills. Looks like a suicide attempt. But what if the blood level is very low for this drug? What if the blood level is so low it could not have caused death from asphyxia? Well, it means, sure, there's sleeping pills in the stomach. Sure, sleeping pills were taken, but they're not what caused the death. So now the medical examiner's got to start looking elsewhere. What could have caused this person's demise? Because it certainly wasn't these handful of Xanax that he found in the stomach. Another place they look is urine. And as I talked before, when things are broken down, they often are excreted from the body in the urine. So urine levels will tell you, well, the amount of a drug in the urine, but it won't tell you how much is in the bloodstream. So what it will tell you is that X drug was present in about this amount at some point in time earlier. And each drug's excreted by a different rate. And so they have to make a best guess as to say, okay, what was the drug level an hour ago or 2 hours ago, and guess at it. But Finding it in the urine only means that it had been in the bloodstream, but was it enough at the time of death to have caused the death? In other words, was the person intoxicated earlier, such as high alcohol levels or something, but death was caused by something else, and this is the classic red herring. That you find it in the urine, but does that really mean anything? Stomach contents, we talked about that. That's another place to look. But finding drugs in the stomach doesn't mean they cause the death unless you can find it also in the bloodstream. Liver, they will check the liver for these drugs because that's where most drugs are broken down. So you can get an assessment of the amount in the livers and you can determine if a drug is there. Now, if it's cleared the bloodstream, say, by the time, so that it's very low in the bloodstream, but it's high in the liver cells and high in the urine, you can say, well, this person was intoxicated with this, X time period ago, and therefore that had something to do with it. One interesting thing is the vitreous humor. Now, this is the jelly inside the eyeball, and it's very interesting. It actually has a relationship with the blood level of many things, particularly, say, alcohol. Now, other thing about the vitreous humor is that it is relatively resistant to decay. In other words, even in severely decayed corpses, the eyes may be fairly much intact because the vitreous decays later on. It takes more time. It's not as susceptible. So you can then access this liquid, yeah, this is creepy, with a needle, and you can test it. All right, let's say that the victim is dead and the blood alcohol and the urine, all this shows some alcohol, but it's not a very high level. Well, you test the vitreous will give you an assessment of what the alcohol level was approximately 2 hours earlier. In other words, the level in the vitreous humor lags about 2 hours behind the blood level. So this can be a useful tool for determining if alcohol had been present. Hair absorbs a lot of things, GHB and all this, but the heavy metals, arsenic, lead, mercury, things like this can be found in the hair. And we'll talk about this later. Hair can also show a timeline because these poisons, these toxins, these heavy metals are only incorporated into the hair as it is growing, because hair is made up of dying cells from the follicles. And so if those follicular cells are saturated with, say, arsenic, then they will incorporate arsenic into that portion of the hair that grows during that time. And let's say then a person is given arsenic for 2 or 3 days in a row, and then they're sick and they go to the hospital, and then the hospital for a few days, and now the levels start dropping, so the amount in the hair starts dropping. And then they get back home and they start getting poisoned again by whoever's doing it at home and preparing their food, and the levels go back up. Well, after death, the medical examiner can take this hair and test for this and get a timeline. Again, we'll talk about more of this later. Another fascinating thing is insects. Now, insects feed on the body. Well, if the body's got toxins in it, the insects absorb the toxins. And there have been cases where the medical examiner has tested the maggots and other creatures that feed on dead bodies and tested them for drugs. Maybe the body is too decomposed to get an accurate toxicological test, but the insects that have fed on the body will contain the toxin. This has been done before. So, we talked about bioavailability and we talked about the breakdown products. We talked about the testing. So let's talk about how the toxicologist relates this to the cause and manner of death. Now remember, there are 4 manners of death. Actually, 5 if you take undetermined. There's natural. That means someone died of a natural cause, pneumonia, heart attack, stroke, something like that. There's accidental, things like self-inflicted, accidental gunshot wounds and car accidents and accidental overdoses and et cetera, et cetera. Suicidal, which means that the person obviously intended to do themselves in and took actions in that regard. And homicidal, which means someone else did this person in. So these 4 manners, you can basically look at them as saying By whose hand and for what purpose did this death occur? Was it by the deceased himself? In other words, was it accidental or suicidal? Or was it at the hand of another, which is homicidal? Okay. The toxicologist has to weigh in on this. He has to determine in his findings, was this death accidental, suicidal, or homicidal? Let's say he knows this person died of a heroin overdose, and he's tested for the morphine product, the breakdown, and he knows the levels are very high, and so the cause of death is asphyxia from an opiate overdose. Done deal. Okay, why did this happen? Well, you can rule natural out because dying of a heroin overdose is not a natural event. Was it accidental? Did the person mix up a little bit and shoot it up and it was more than they thought and they quit breathing and they died? Was it suicidal? Was the person saying, I've had enough of this, I'm going to do myself in, nobody loves me anyway, and so they mix up 5 times as much as they normally do and shoot themselves? Or was it homicidal? Did someone want to get rid of them? So let's say the a body is found in an alleyway in a street. It happens all the time, and the person has died of a heroin overdose. Okay, was it an accident? Person shot up, forgot he did. 30 minutes later, did it again. Too much, quit breathing, died. Was it suicidal? Goodbye, cruel world. I've had enough of living on the streets. I can't. I'm tired of robbing people. I'm tired of doing all the stuff I have to do to feed this monkey, and I'm just going to do away with myself. This happens all the time. Or let's say that individual had been talking to the police. Maybe he was a snitch, a CI, whatever, or at least his supplier thought so. So his supplier sells him another nickel bag. Well, most of these are 10 to 15% heroin, and the rest of it's whatever he wants to put in there. That's how they cut it or step on it, all that. Those are the terms for that. But let's say he gives him something that's 90% pure. Well, this guy doesn't know the difference. All he knows is he takes X amount, put it in the spoon, heats it up, draws it up, and shoots it in his vein. Well, it's 6 times his normal dose. And so he lays down, goes to sleep, quits breathing, and dies. So you can see the difference. But to the medical examiner at autopsy and with toxicological testing, they all look the same. There's too much heroin breakdown product in the system, and it's enough to make the person quit breathing and die. The rest of it is police work to determine. Now, there's a few things the medical examiner can do. One is look for injection marks. Now, if the injection is in a position that the person would not likely or would have comfortably done it that way. A lot of people talk about the crease, the folds at the bottom of the buttocks, that's a good place to give a little injection if you don't want the drug to be found. It's been used in insulin murders and stuff like that. Well, you wouldn't do that if you were going to overdose it or if you're just shooting up heroin to have fun and it's an accident. You just wouldn't do that. So they have to find that injection site, and the medical examiner might say, whoa, wait, this is not a comfortable position. This person could not have contorted himself to do this. Therefore, someone else must have given him the injection. So these are the kinds of things that the forensic toxicologist is faced with, and it's not an easy job. It takes a very smart person, and it takes a diligent adherence to protocol when you go through all this testing and come up with all these answers. So basically, anything can be a poison. A drug is something that makes you better. A toxin is something that makes you sick. And a poison is something that kills you. But they're all the same thing, and it's a matter of dose. Remember in the beginning, I said, taken in sufficient quantities. So we've looked at some of these. We've looked at the general principles, the types of samples that are obtained, how to interpret the test as far as cause and manner of death, the insects, the vitreous humor, the other thing, the places that the medical examiner looks for stuff. So this is part 1. As I said, we will get to part 2 and part 3 very shortly, and those will be posted later. And I hope this proves useful. I hope that it helps you create some of your cool thrillers and mysteries. I know poisons are near and dear to crime writers' hearts because they're so effective and so clever and cool ways to kill people. And you know the beauty is the killer can be a long way away when it happens. So that means your sleuth, your cop, your PI, whoever has to figure things out, and that means that they got to be really cool, clever characters, which is what storytelling is all about. So this has been Toxicology Part 1, and this is DP Lyle, your host, and until next time, have a great day.